In this video, you will learn how to experience significant speedups and maximize your performance in FieldView. To achieve these speedups and performance improvements, users can run FieldView in parallel. Let's start by reviewing some of FieldView's MPI parallel basic principles. FieldView uses hybrid parallelization, which is a mix between multi-threading, where multiple threads are used for each process, like computing streamlines or formulas, and MPI parallel, which can efficiently distribute the loads of heavy operation through all available nodes that you have available. We will focus in on MPI parallel for this video. The result of using MPI parallel has been faster read times and improved performance with heavy operations in FieldView. Let's walk through some real cases that demonstrate the benefits of MPI parallel. The first case we're going to look at is an unstructured case from Fluent. Here we see a lot of grids of various sizes. For the benchmarking test, the case was read, the geometry of the Formula 1 car was computed, and the ISO surface was computed using the native Q criterion calculation in FieldView. Even though the grids weren't fully balanced, we still see a 3x speedup on 8 cores versus serial, and when we go to 64 cores, we see a 4x speedup. So pretty good performance improvements when taking advantage of MPI parallel. The second case we're going to look at is an unstructured case from OpenFOAM. This case is 2 Formula 1 cars following each other, and is an ideal case for MPI parallel, since the grids are equally balanced. Performing the same benchmark as the previous case, we see a 4x speedup with 8 cores from serial, and a 14x speedup with 64. So that gives you an idea of what is possible if MPI is fully utilized. Now let's look at a third case that has unbalanced structured grids. The grids are partitioned into 5 large grids and 12 smaller ones. With this unbalance, we don't experience the same performance improvements as we did in the previous cases. Unless something is done to balance the partitions, you can see that the speedups with MPI parallel are minor. Luckily, FieldView has a solution in the form of our auto partitioner. The auto partitioner takes care of load balancing issues, where large blocks are preventing an even distribution across processes. The auto partitioner, which is embedded into FieldView, does a partition on the fly at read time and smartly cuts up the structured grids, and evenly redistributes the new partitions across available nodes, which will then allow users to take full advantage of the MPI parallel capabilities in FieldView. Now let's look at case 3 again with the auto partitioner applied. We now see better speedups and performance improvements. The question we typically get is, will my workflow benefit from MPI parallel? As you can see from this diagram, the operations where you will experience the fastest speedups are things like data input and computing ISO surfaces with MPI parallel. Operations like rendering are not affected by MPI. In the example we see here, cut planes are being rendered at different locations. When MPI parallel is utilized, we see a huge improvement with the data input, a good speed up with coordinate surfaces, but no difference with the rendering operation. Since this workflow is rendering dominant, we don't see a lot of benefit with MPI. In another example, we see a transient animation where the data is input, an ISO surface is computed, and the image is rendered. This cycle is repeated for the following time steps. We see a huge improvement in speedup in this case, since operations such as data input and ISO surface computation are significantly impacted by MPI. So try using MPI on the cases you are running today. Most common licenses today can run parallel on up to 8 cores, so try to take advantage right away. We have upgrade options to run on more cores, which can help you fully utilize the benefits of MPI. And we are willing to work closely with our customers to ensure your data is being output in an ideal way for MPI parallel. Contact us if you want to have a further discussion about MPI parallel, or if you want to try a parallel license with your datasets.